All right, everyone. Today we're going to learn how to solve literal equations. And the first thing we need to know is what is a literal equation? Well, here's a pretty good example of a literal equation. And the big difference that you're going to notice from a regular equation is that there are multiple variables in there. Typically, a literal equation will be very similar to like a formula where the variables might stand for something like distance or time or speed. So what we're going to be learning how to do is instead of solving for x and getting a number, we're going to learn how to solve for x and have our answer still be in terms of those other variables. This is going to help us learn how to manipulate and alter formulas so we can get them in a format that works well for us. Okay, actually, that last equation was a pretty good one for our purposes here, and it can kind of help illustrate a point. Let's say that we were solving for x, so we're trying to figure out what x equals for this one. What we have to realize is there are some things that we have to get to the other side of the equation, okay? So you're still trying to get x by itself. We're trying to move the 6y over to the other side and the 3 over to the other side. And there's a difference between those. 6y we're moving as all one piece, and there's a plus sign before it. 6y is a term. Okay, terms are something that are added or subtracted in the equation. Okay, whereas the 3, you might have heard this word before, it's called a coefficient. And it's a coefficient is any number that is multiplied or divided by the variable. Okay. So what we have here is 3 is being multiplied by the variable that we're trying to solve for, right? If you look at the 6 on 6y, 6 is also a coefficient, but we're not trying to get rid of just the 6. We're trying to get rid of the 6y as a whole piece, and 6y is being added, so that's considered a term, okay? So in terms of getting rid of a term versus a coefficient, you are going to solve this equation very, very similarly to the way you would solve it for x if there were no other variables involved at all. So what I've done over on the side here is I've rewritten our equation, and I've also then rewritten it again, but without the y and the z, because what you're going to find is you're actually going to work these very much the same way. Okay, so as an example here, you're going to subtract 6 from both sides, and then you would divide by 3. You're actually going to perform pretty much the same set of steps on this, except instead of subtracting 6, you're going to subtract 6y. Okay, terms you can get rid of by addition or subtraction. Okay, so you're really doing the same thing that you would do if it was a regular number. The big difference here is now I can't do 9z minus 6y because they are not like terms. So instead of actually trying to perform math to combine them together, since I can't do that, I just leave them separate over on my other side. I get rid of coefficients the exact same way I would, except with the difference being if I have multiple terms over on the other side, I'm going to need to go ahead and divide both sides, both terms by that number. So I'm going to divide both 9 and 6 by 3, and I get x equals 3z minus 2y. Very, very, very similar steps in solving a literal equation versus solving a regular equation. Okay. Why don't you guys try B? You're solving for C there. Okay. Try to solve for C and then come back. Okay. I'm assuming you've done that. Again, we're trying to get rid of 5y and then just the 3. So again, imagine what you would do without the variables there. We'd probably subtract 5 first. We're going to subtract 5y instead. I get 3c equals 12 minus 5y. Then divide everything by 3. Now, it's a little bit your choice. You could actually do this one of a couple ways. You could divide that whole side by 3, and you could leave your answer like that. That's one possibility. Or You could divide them individually by 3. That would be okay too, and that would allow you to simplify there and leave that as a fraction. I wouldn't recommend turning it into a decimal. Both of these answers are definitely acceptable. You could put either one. C is a example I threw in there because it's probably been a while since you solved a proportion. A lot of times what you're taught to do here is to cross multiply. Okay, and I'll show that method here, but be prepared in class to explain why this cross multiplication method works. So cross multiplication works, first of all, only when you have a fraction equal to a fraction. You multiply the diagonals together, 3CR equals 2XY, and you create a new equation. The benefit of doing this is that now you've gotten rid of your fractions completely. Again, as a reminder, we're trying to solve for x in this one. My x is over here. 2 and y would both be considered coefficients because they're both being multiplied by x, so I can get rid of those with division. I'm going to divide both sides by 2y. Nothing cancels, and I just get x equals 3CR over 2y. So what you'll find is solving a literal equation is oftentimes very similar to what you do when you're solving a regular equation, but you're going to have variables as a part of your answer.